Here we'll talk about the basic rules for naming alcohols. The first step, of course, is to find the functional group. Look for that hydroxyl group. That indicates that the ending for the name will be OL. In this unit, we will only have one type of functional group present, which means that the rest of the hydrocarbon chain is an alkane. So we will put AN in front of the OL, making it anol. If there had been a double bond, we would put an ene. If there had been a triple bond, we would have put -ine. But again, in this unit, we will only see one functional group, so all of ours will have AN in front of the OL. Next, we need to find the longest continuous carbon chain. That includes the carbon that has the hydroxyl attached to it, even if it is not the longest total chain. The hydroxyl group is so important that it tells us the class of compound and tells us where reactions will occur. So we must include the carbon that has the hydroxyl group as part of the main chain. We'll use our regular numbering system to indicate how many carbons are in that main chain. Now we have to number everything. So we're going to number, giving the lowest possible number to the hydroxyl group. Once the direction of numbering has been determined by the hydroxyl group, we can add the substituent groups in and number those, using the direction that was determined by the hydroxyl group. Recall that any time there is more than one of a group, you can use the prefixes di, tri, and tetra, and they will never be a part of the alphabetization. So let's try some. Let's start with alcohol A. We find the hydroxyl group. The ending then will be OL. We put an AN in front of that to indicate that everything else is a hydrocarbon chain that is single bonded. And then in front of that, we indicate how many carbons are in the main chain. In this case, we have just one carbon, so this is methanol. We would put a number in, and that number would be 1. But in this case, we are not required to write the number 1 because it could only be on carbon 1, because there's only one carbon. That means the whole name here is methanol. Now let's look at compound B. For compound B, we find the hydroxyl group. The ending will be OL. We see that everything else is single bonded, so we're going to put an AN in front of the OL. Now we're going to count how many carbons are in the main chain. We just see 2 carbons. We say eth for 2 carbons, so this is ethanol. Now let's number where the alcohol is. Counting in the forward direction, it would be on carbon number 2. Counting in the reverse direction, it would be on carbon number 1. We're going to choose the lower of the 2 numbers. That would make this 1-ethanol. But do we actually need that number? Let's see. So if I draw the 2 carbons again, and I put the OH on the other carbon, what number would it be now? That's right. It's still 1-ethanol. That means that we do not need to have the number on the name. This is just ethanol. Now let's look at compound C. Here's our hydroxyl group, telling us that the ending will be OL. We look at the rest of the carbons. We see that they're all single bonded, so we put an AN in front of that. We look to see how many carbons are in the main chain. We see 3. We say prop for 3, so it's now propanol. And now we need to number it. Counting in the forward direction, the hydroxyl would be on carbon number 3. Counting in the reverse direction, it would be on carbon number 1. So our answer should be 1-propanol. Do I need to have that number? To determine that, let's redraw the compound. We're going to move the hydroxyl over 1 carbon, and then we'll move it over 1 more after that. So we're going to redraw it twice this time. So if the hydroxyl is on the middle carbon, this would become 2-propanol. And if it's on the other end, it is 1-propanol again. So we see that these two are the same, but we do have one different one, and that's 2-propanol. So yes, we are required to put the number in for this alcohol. So let's continue with our naming. Now what we'll notice is that these compounds all have a name underneath. That is a common name. You do not need to know the common name of these chemicals. So you do not need to memorize those. I will only be asking you to name them using the IUPAC naming system. Starting with compound D. First we find the hydroxyl group. That tells us that the ending will be OL. We notice that everything else is single bonded, so it's ANOL. We find the longest continuous carbon chain that includes the carbon that has the hydroxyl on it, and we see that we have 3 carbons. That'll be prop, so we currently have propanol. We count in the forward direction, the OH will be on number 2, and in the reverse direction it is also on carbon 2. So this is 2-propanol. And yes, we are required to number it because as we saw in the previous notes, 1-propanol is another structure that is possible. The common name for this is isopropyl alcohol, or sometimes isopropanol, and at the store it's usually called rubbing alcohol. For alcohol E, we find the hydroxyl group, we end the name with OL. Notice that everything else is carbon-carbon single bonds, and so we have AN for the alkane part of it. Next, we say how many carbons are in the main chain that includes the carbon with the hydroxyl on it, and we see that there are 3 carbons. 3 carbons is prop, so we have propanol again. Now, before we add any substituents, we must number the compound in order to give the hydroxyl group the lowest possible number. The hydroxyl, again, takes priority. So we see that in the forward direction, the hydroxyl will be on carbon number 2. In the reverse direction, it will also be on carbon 2. So this is 2-propanol so far. Let's add in our substituent groups. We have a 1-carbon substituent. That is going to be called methyl. So we'll put methyl in front of the number 2, and then we'll have to number that methyl group, and it is also on carbon 2, so this will become 2-methyl-2-propanol. And for letter F, we're going to find the hydroxyl group. Now notice that there are 3 hydroxyl groups, so this ending will not just be all, but it will be triol. The next step is to put AN in front of that to say that it is all single bonded. But we're also going to add in the letter E. So it's ane triol, and that's just to make it easier to speak, so we don't have NT, which is a little more difficult to say. The next step is to look at how long our hydrocarbon chain is. That includes all of the carbons that have hydroxyls on them. In this case, that's 3, so that will be prop. So we now have propane triol. We just need to number it. If we count in the forward direction, we see the alcohols are on carbons 1, 2, and 3. And in the reverse direction, we see that they are on 1, 2, and 3. So our name will become 1, 2, 3 dash propane triol. Now let's practice drawing those alcohols from a given name. When we look at compound A here, we can identify it as an alcohol because its ending is OL. Next, we see that everything else is single bonded, but most importantly, we see that there are 5 carbons in the main chain. So let's draw those 5 carbons. Now we're going to put the hydroxyl on. What carbon should that be on? That's right, it should be on carbon 3 because this 3 in front indicates where the alcohol is. Everything else is still single bonded. Now we just need to do our attachment, and we'll find that there's a methyl group, which is a 1-carbon chain that is on carbon number 2. And finally, we add in the right number of hydrogens so that there are 4 bonds on every carbon. Remember that oxygen only gets 2 bonds, so it is already done. And that is your 2-methyl-3-pentanol. So is this a primary, secondary, or tertiary alcohol? Recall that we look to see where the hydroxyl group is attached. We see here on number 3, the carbon that it is attached to has 2 carbons attached to it. That makes this a secondary alcohol. Now let's look at alcohol B. Again, we know it's an alcohol because it ends with OL. We know all the carbon-carbon bonds are single bonds because of the AN. And we see that it has a dec. Deca means 10 carbons, so we're going to make a 10-carbon long structure. The next thing we want to do is indicate where the hydroxyl group is attached. The hydroxyl group is on carbon number 4. Now again, you can pick the forward or the reverse direction. It doesn't matter. You can put the OH going up. You could go down. Again, it doesn't matter where exactly you put it, but it should be on the 4th carbon from the end. I'm putting mine going from the left because I normally count that way. It is not necessarily the only way to go. Now we can add on our substituents. We see that we have 2 methyl groups because it says dimethyl, and we have a propyl group. Methyls are 1 carbon each, and a propyl group is 3 carbons. So where do they go? We see that both of the methyl groups go on carbon number 3, so I'm going to put 1 going up, 1 going down, and we have our 3,3 dimethyl group done. And next we're going to put on our propyl group. We'll go to carbon number 4, we'll put on 3 carbons, and now we have our carbon skeleton. The last step is to add on all the correct number of hydrogens. Again, making sure that each carbon has 4 bonds and that the oxygen only has 2 bonds. And that is our 3,3 dimethyl 4-propyl 4-decanol. So what kind of alcohol is it? Is it primary, secondary, or tertiary? We look at where the OH is. It's on carbon number 4. That carbon has 3 carbon chains coming from it, and so it is a tertiary alcohol. And finally, let's look at alcohol C. We know this is an alcohol because it ends with OL. I see that there's a di in front of it. That tells me that there are 2 hydroxyl groups. Then I see it's AN in front of that, and that tells me that it is all single bonded. And we can see that the main chain has 6 carbons because it's a hexanediol. The hex telling us 6 carbons. We'll start there. Once I've placed those carbons, I can now put on the hydroxyl groups. In this case, I have 2 of them. One of them will be on carbon number 1, and the other one will be on carbon number 6. Again, I am counting from left to right, but you may go in the reverse direction. Once I have those hydroxyl groups placed, I can now attach other groups. I'm going to start by attaching a fluorine onto carbon 1, and then I'm going to put an isopropyl onto carbon 3. So you'll need to remember what an isopropyl group is. It is a 3-carbon chain attached at the middle of those 3 carbons. So on carbon number 3, we're going to put 1 carbon and add 2 carbons, 1 on each side of that attached carbon. We now have our carbon skeleton. And the last step is to add in our hydrogens to make sure that we have 4 bonds on each carbon and 2 bonds on the oxygen. And that is our 3-isopropyl 1-fluoro 1,5-hexanediol. So is this a primary, secondary, or tertiary alcohol? Well, we're going to have 2 of them in this case, so let's see. The one on carbon number 1 is going to be a primary alcohol because the carbon it is attached to has only 1 carbon coming from it. The one on carbon number 5 is a secondary alcohol because carbon number 5 has 2 carbons coming from it, so it is secondary. This alcohol is both primary and secondary.